Hello and welcome to PetXI Interactive, the home of GCSE revision on the go. Every time I see some numbers, I can't help myself. I have to see if there is some sort of pattern. I just can't help but get my calculator out and start tapping away. After this maths burst on sequences, you'll be noticing them everywhere as well. Okay then, so sometimes you get basic questions where you just need to extend the sequence. Those are really quite straightforward, as it's just about spotting the pattern and continuing it. We are instead going to focus on more tricky questions involving a strange thing called the nth term. If you see the nth term, don't panic. The nth term is just a rule that's used to describe a sequence which uses the letter n. There is a number that goes before the n and a number that goes after the n, and it's these numbers that we must find. Let's jump in with an example. Here's a sequence for us to have a look at. 3, 7, 11, 15 and 19. What's the pattern? What are the numbers going up by each time? In this case, they are going up in 4s. This is really important, as it is the number that goes before the n in the nth term. So now we have 4n. Halfway there, now for the number that comes after the n. We can take the first term and think about what number would come before it if we reverse the sequence. Well, because the sequence goes up in 4, the reverse is to take away 4. That would give us -1. This is really important, as it's the number that goes after the n in the nth term. So putting all this together, the nth term is 4n minus 1. You might be thinking, why do I need to find the nth term? Is it even important? Well, once we have the nth term, we can find out any term in the sequence using our good old friend, substitution. If you're not clear on substitution, it might be worthwhile watching our video on the topic. So this time, let's start with the nth term, 6n minus 2. n actually represents a position in the sequence. By substituting that position for the n, we can find out what the value of that position in the sequence would be. So, for the first term, which is position 1 in the sequence, we replace the n with a 1. So 6 times 1 is 6. Take away the 2 is 4. For the second term, which is position 2 in the sequence, we replace the n with a 2. So 6 times 2 is 12, minus 2 is 10. Do you get the idea? For the third term, position 3, we replace the n with a 3. So 6 times 3 is 18, then take away the 2 is 16. So far, we have 4, 10 and 16. If we wanted, we could even find the 10th or 100th term. For the 10th term, we replace the n with a 10. 6 times 10 is 60, minus the 2, 58. For the 100th term, we replace the n with 100. 6 times 100 is 600, minus 2 is 598. So, we've looked at making the nth term and using it. Sometimes the exam paper may try to confuse you with shapes instead of numbers. If you see a question with shapes, it's actually easier to write down some numbers. For example, how many sticks will make up the next pattern in the sequence? Underneath each shape, let's write down how many sticks are there. 1, 4, 7 and 10. We can see from the numbers that the pattern is going up in 3s. So, adding 3 to the 10 sticks gives us 13 sticks, which is our answer. Excellent. So hopefully, when you next see a pattern, be it of numbers or sticks or anything else, you can impress all those around you by telling them what the millionth value in a sequence would be. Thanks for watching, and see you again on another episode of PetXI Interactive Maths.